Okay, ask someone now Tarkesh to join. Someone ask Tarkesh, I don't know whose friend he is. Okay. Veda Prakash, call him and ask to join now.
Okay.
Yeah, what is a priori property?
All
Non-empty
non-empty
subsets of
subjects
the
of the
item
frequent
sets
item
must
set
also be
must
frequent.
also be frequent.
Okay. And what are the two important rules we keep in a priori algorithm?
Join step, prune step.
Join set and
Okay, Durga Prasanna. Okay. Yes. With these basic points, we will see the algorithm for a priori algorithm in today's class, and we will also see the drawbacks of a priori algorithm. Um, when you are seeing this algorithm, basic thing for any algorithm of all these data mining algorithms will be like initially you should be able to understand what the input is, what the input is, what the outputs are, and in what way we want that outputs to be presented or to be visualized. Inside that, what are the properties we are keeping inside that algorithm, which is nothing but the logic of that algorithm. So these are the things we have to maintain in any algorithm of your data mining concepts. Now, what are the inputs to your a priori algorithm?
Frequency.
Hmm? What?
Frequency, ma'am.
Chandu, sequencing.
Frequency, ma'am.
Frequency. Tell in a proper way.
We have the
frequent
transaction
item set,
and
ma'am.
list of
Frequent item
Item
sets,
sets,
ma'am.
ma'am.
Pallavi, you are about to tell something.
we have the transactions with the list of items
Transaction,
and the list of items.
transactions, and the list of items, where we are keeping them. Those transactions and the list of items where we are keeping.
Transactional
A
database.
transactional state.
Yes, Mahesh and Pallavi. First initial thing is transactional database, yes, which is good, which consists of the transactions and the item sets. Good. Next. Next.
Minimum support, ma'am.
Yes. Minimum support. Durga Prasanna. Minimum support we have to provide. What is the minimum support? Inka. With these two inputs, what will be the logic we have to keep inside? Sorry, before we go to the logic, what is the output we get from a priori algorithm?
Frequent items.
Most
Yes.
frequently used items.
Mahesh and Pallavi, your turns are over. For next remaining questions, we will give the chance to the others. Okay. Yeah, the output is we will be getting frequent item sets. The output of a priori algorithm is frequent item sets. The input is minimum support and the transactional database, which consists of transactions and the item sets, and the output is frequent item sets and its combinations. Now, what is the logic we have to keep inside? Veda Prakash, no chappu. Unmute your system and tell. I didn't get Veda Prakash.
I didn't listen to question. I'm just taking the roll numbers for it.
రోల్ నెంబర్స్ ఇవన్నీ తర్వాత చెక్ చేయండి అయ్యా, ముందు క్లాస్ వినండి. క్లాస్ ఇంపార్టెంట్. రోల్ నెంబర్స్ వచ్చేవాడు వస్తాడు, రానివాడు ఎవడికి అవసరం. ఫస్ట్ క్లాస్ ఇస్ ఇంపార్టెంట్, తర్వాత మీ అటెండెన్స్. Moreover, I want all your videos switch on. Yeah. Somebody is telling something when I'm talking with Veda Prakash. Now tell me, what is the logic you have to keep inside that Apriori Algorithm?
We filter the items that doesn't satisfy the minimum support.
Sai Teja, repeat.
We first form a candidate item set, ma'am, candidate item table, and then from that we filter the item sets which doesn't satisfy the minimum support.
Good.
So
That
thus
is
we form a frequent table.
very good. Good. That is one good point. Yes. We have to create one data structure, candidate table, candidate generation table, and from it we will be getting the frequent item sets. And how we will be getting this, whichever the items does not satisfy the minimum support, we are going to filter from that candidate item and forming your frequent item set. Good. Yes. Inka. What is this called, Sai Teja? Whichever are not supporting minimum support, we are not going to keep it in the frequent item set. Even the
Prune step, ma'am.
Listen properly.
Sorry.
Even the subsets which are not forming, which are not supporting the minimum support, which are not having the minimum support, we are not going to keep it in the frequent table. What is this called? Prune step. Yes, it is correct. And also and now I repeat again, whichever the items are not having the minimum support are not kept in the frequent table. Whichever the items in the candidate item table does not support the minimum support are not kept in your frequent table. That is the prune step. That is correct. And what I say is, whichever the subsets of your items from your frequency table, from your frequency table, that is from, this is the next step, which is whichever items from your frequency table and the subsets of those frequent item table are not kept in the candidate item set, that is called as
Anti-monotonous.
what is anti-monotony?
All subsets of a frequent set should be frequent.
Frequent.
What is that called as? Citation.
Apriori property. Apriori property.
Yes, all of you mute your systems. That is what your a priori property is. So when you are not transferring the subsets from the frequent item set into your candidate item sets because they are not frequent, that property is called as a priori property. So you have considered the prune step, a priori property, and left over with the join step. So the join step you will be keeping, you will consider two item sets of the same frequent item set table, two item sets of the same frequent item set table, see that they are common up to n minus 1, and the last nth item should be less than or equal, less than the first item set than the second item set. So this is what we have seen the join step. Instead of n, we are keeping that if we are forming CK, we are taking that from LK minus 1 and we are seeing up to K minus 2, they are equal, and K minus 1 the item should be less than the first and the second item sets. So these are the things we keep in the a priori algorithm. So we have seen what is the input, output, logic, properties and all. The same thing we will see in we shall see the same steps in this algorithm here. So this is what your algorithm is. If you know these points very easily, you can understand. Now see this input. The initial one
Ma'am,
is
you did not share your screen.
oops. Okay. One second. Better all of you take the steps. Write down these steps. Can you see now?
Yes, ma'am.
Oh. Now this is what the algorithm to find the frequent item sets using an iterative level-wise approach. Now see this one. Input is a database of transactions and minimum support, which we are taking into the variable minimum underscore SUP, the minimum support count threshold. Now, are you clear with this D and minimum support with the input?
Yes,
And yes, and the output L, frequent item sets in D. L is frequent item sets in D, that is the output we are expecting. Now, see the logic from here to here. L1 is equal to find frequent 1 item sets of D. Find frequent 1 item sets of D. This is the total function. Find frequent 1 item sets of D is one function which we have taken the parameter to be as D, and because this is 1, here we are having frequent 1. This is the output of the complete this one, we are going to keep it in L1. Okay, now see the same thing here. Here we are having LK minus 1 to find frequent K minus 1 item sets. Find frequent K minus 1 item sets. Okay, these are the two function names we are giving. Just keep that function aside. Keep it aside. Now, take this one, take the second one. For K is equal to 2 to Lk minus 1, until your Lk minus 1 not equal to null, we are increasing that K plus plus. And for that, we are going Ck is equal to a priori generation Lk minus 1. A priori generation of Lk minus 1. Where is your a priori generation of Lk minus 1 is here, and finding the frequent item sets opposite to that is we are having as infrequent subsets. What we want is frequent item sets, but here we are having infrequent subsets. So in this infrequent subsets, whichever is in the false, we will keep it in the frequent item sets. Whichever is true, it will go into the loop again. We will come back to this again. First we will see this join step and then we'll come back to this. So here from K is equal to 2. K is equal to 1, we are finding frequent 1 item sets, nothing but scanning your database, and of course this we will be taking from C1 only. Your L1 will be coming from C1 only, that we will see here. Before that, we will see your this a priori generation. Now, what is this a priori generation here is, we are trying to find out Lk minus 1 frequent k minus 1 item sets. So the parameter for this a priori gen is we want Lk minus 1. The parameter for L1 or Lk minus 1 is we want k minus 1 item sets. Here initially L1, the parameter is D. Here for a priori gen, the parameter is Lk minus 1. Now, this is the join step. If you see this one up to this part. So the join step is for each item set L1, which belongs to Lk minus 1, and for each item set L2 that also belongs to Lk minus 2. These two are nothing but I1 and I2, just the immediate item sets of Lk minus 1. So if I take this one, here I1 comma I2 will be your small L1, I1 comma L3 will be your small L2. Did you understand?
Yes.
Yes. So taking those two item sets, if L1 of 1 is equal to L2 of 1 and L1 of 2 is equal to L2 of 2 until your k minus 2. Until your k minus 2, they should be equal. And what is the last one is your L1 of k minus 1 should be less than L2 of k minus 1. If that is the case, what you will do is you join your L1 and L2, small L1 and L2, which is the join step. What can be the output of this L1 join L2 now? C is equal to what will be the output of this C? What are the values of C, small c? Now I will tell. If my L1 is equal to small a, b, c, d, my L1 is equal to, write down there, my L1 is equal to a, b, c, d, and my L2 is equal to a, b, c, e. My L2 is equal to a, b, c, e. What will be my C here?
ABCD.
AD,
ABC.
ABC,
ABC mean. But
wrong. ఇంకొక ఆన్సర్.
ABCDE, ma'am.
Yes. ABCDE, Durga Prasanna. What is this ABCDE? నేను అదే నిన్న క్లాస్ నుండి చెప్తున్నాను ఏంటంటే, up to n-1 you take all of them as it is into the new join. అన్ని జాయిన్ చేసేసుకొని వాట్ విల్ బి ద లాస్ట్ టూ ఐటమ్స్ ఏంటి అని అంటే, ఇందులో ఉండే లాస్ట్ ఐటమ్, ఇందులో ఉండే లాస్ట్ ఐటమ్ విల్ బి ద లాస్ట్ టూ ఐటమ్స్. అప్ టు ద కామన్ ఐటమ్స్ you will have the common thing. I better have something to show you. Can you see this?
Yes, ma'am.
Yes, ma'am. Yes. See, if your L1 is equal to ABCD and your L2 is equal to AB. So if these two are L1 and L2, now what is that we are doing is L1 joining your L2. What we will be getting is all your up to D and E, all the three are common. So what is the output is A, B, C, D, D and E. This is what your L1 and L2. When you are taking this L1 and L2, this is the 4-item frequent item set. These are 4 items are there, and your L1 and L2, they are the item sets of L, capital L. So, the capital L, if you take a table, these are all your item sets. I think the capital L lo, these are all your item sets, and what I'm saying is your L is a 4 item frequent sets. Ante transaction L1, L2, L3 all should have compulsory 4 item sets. Now, when you join this L1 and L2, the output of that is a 5 item set. దీని అవుట్పుట్ ఏంటంటే 5 ఐటమ్స్ సెట్ ఇట్ షుడ్ బి. సో వాట్ ఆర్ ద 5 ఐటమ్స్ దే షుడ్ బి ఈస్ all these 3 items from your L1 and L2, those 3 should be common. Fourth item will be the last item in L1, fifth item will be the last item in L2. Are you all with me?
Yes, ma'am.
Yes, okay. That is what the join happens in your this algorithm. That is the step. What is the output of your C is, if your L1 and L2 are 4 item sets, your C will be getting 5th item set. Now, after you keep that in C, now check whether it is frequent or not. If it is frequent or not, what you have to do is, again, for each and every after join, you have to go back to your transactional database and check the frequency. So now again, what you're asking is if it has infrequent subsets. If it is having infrequent subsets, if the true of this function is true, now you delete that C, which is what your crude step. So how do you know this is infrequent or not is come to this procedure here. If you come to this, now see the parameters of this infrequent. You should have see the candidate K item set. This is what K item set is already we have obtained candidate K item set, and we should have LK minus 1, which is having K minus 1 frequent item sets. So which means that to find out whether it is having frequent item sets or not, now see this one. You should have, if you take this one, C3 is already there, L2 is there. ఈ రెండు ఉంటే then you will obtain a C3 which is having minimum support count. These are the item sets generated from L2. Once they are generated, then you keep it into C3, which are satisfying this support count. So ఇది వచ్చిన తర్వాత ఇది తెలియాలి, ఇది రావాలి అని అంటే ఎవ్రీ టైమ్ యూ హ్యావ్ టు స్కాన్ దిస్ వన్. ప్రతిసారి దీంట్లోకి వెళ్ళి ఆ సీక్వెన్స్ అనేది దిస్ వన్ ఈజ్ I1, I2, I3 అనేది you have to count how many times it is there and then keep this count here. Consider only whichever are having the frequency, then consider only into this L3. And the subsets of this, before you keep into this one, the subsets of this also should be in L2. That is one more important thing. Now that is what you will be checking here. So the infrequent subset, the parameters are C and LK minus 1 to get the frequency to keep it in CK. Now, for each K minus 1 subsets S of C. So for each K minus 1 subsets S of C, if S does not belongs to LK minus 1, then return true. అర్థమైందా? ఇది ఈజీగా అర్థమైందా? Very easily. If the subsets of K minus 1 in C are not there in LK minus 1, return true. So return true అంటే ఏంటి ఇక్కడ? We'll see again. Answers you should tell. నేను ఆన్సర్ చెప్పను. You have to tell the answer. Keep your total mind and concentration on what I'm saying. ఇక్కడ ఏం చెప్పాను? This is the C3 I have got, and to get this C3, 2 things I have to do. To get this C3, what I have to do is find out all the subsets of this, whether they are in LK minus 1. ఇందులో ఉన్నాయో లేదో చూడండి సబ్సెట్స్. సో ఇందులో సబ్సెట్స్ ఉంటేనే యూ క్యాన్ కీప్ దట్ ఇన్ టు దిస్ వన్ థింగ్. ది సెకండ్ థింగ్ ఏంటి అని అంటే యూ హ్యావ్ టు స్కాన్ దిస్, కౌంట్ దిస్, దట్ సీక్వెన్స్ ఈస్ దేర్ ఇన్ యువర్ దిస్ పాయింట్. ఈ సీక్వెన్స్ కూడా ఇందులో ఉందా లేదా చూసి ఇందులో వేస్తారు. అలా ఉంటేనే యూ గో ఫర్ దిస్ వన్. ఈ సబ్సెట్స్ కనుక ఇందులో లేవు అని అంటే ద సబ్సెట్స్ ఆఫ్ C3 ఇఫ్ దే ఆర్ నాట్ ఇన్ L2, CKలో ఉండే LK-1లో సబ్సెట్స్ లేవు అని అంటే you will not bring that into here. Now see this one here. If you take this particular one, C2, and we are trying to keep it in L2, ఈ C2 నుంచి ఇది రావాలి, ఇక్కడికి రావాలి అని అంటే what we are doing? We are scanning the D. That scan D every time we should go ఇందులో scan ఇందులో పెట్టేసి, and what we are doing, what is that LK-1, ఇక్కడ C2 కాబట్టి we are going to L1. ఈ L1లో సబ్సెట్స్ ఫ్రీక్వెంట్ గా ఉన్నాయా లేదా చూస్తారు ఇక్కడ. One thing is whichever are having 1 0 1 0, we are removing that is one thing, and the other thing is all the subsets are there in L1 or not, that we are keeping. ఇక్కడ మనకి సబ్సెట్స్ అన్నీ కూడా ఇండివిజువల్ గా వస్తాయి కాబట్టి I1 I2 and every I1 I2 are there in L1, we can consider all these I1 I2 and all. What we are removing is whichever are having 1 and 0, we are not keeping that into L2. ఇక్కడికి వచ్చేసరికి ఏమవుతుందంటే when you come to this C3, we are scanning the D, and ఇవన్నీ ఉన్నాయి, that is one thing, and whichever are not having the subsets, we will not keep this into here. సో ఇక్కడ అన్ఫార్చునేట్లీ ఏమైందంటే మీకు అది ఎగ్జాంపుల్ చూపించడానికి ఇక్కడ ఆల్ ద సబ్సెట్స్ ఆర్ దేర్ హియర్, వీఆర్ కీపింగ్ దట్ హియర్. లేదు అని అంటే వీ విల్ నాట్ కీప్. సో దట్ ఈస్ ద థింగ్. నౌ what my question here is, for each K-1 subset S of C, we are going to find out this. ఈ సబ్సెట్స్ అన్ని కూడా ఇందులో ఉండే సబ్సెట్స్ ఇందులో ఉన్నాయా లేదా అనేది వీఆర్ చెకింగ్. ఫర్ ఈచ్ K-1 subset S of C, if S does not belongs to LK-1, then return true. My question is, if it is return true means what does this particular function is telling?
This is the final frequency.
Final output. This is the final output because there is no subset of first.
ఏంటి ఫైనల్ అవుట్పుట్? ఏంటి ఫైనల్ అవుట్పుట్? ఫైనల్ అవుట్పుట్ అంటే ఏంటి? ఆ పర్టికులర్ ఫంక్షన్ కి చెప్పండి. ఆ ఫంక్షన్ యొక్క అవుట్పుట్ ఏంటి? ఆ ఫంక్షన్ లో 4 లైన్లు ఉన్నాయి. స్టార్టింగ్ ఫ్రమ్ ద ఫంక్షన్ నేమ్, సీ దట్ లైన్స్ అగైన్. అందుకే చెప్పాను కాన్సెప్ట్ సరిగా ఫాలో అవ్వండి అని. ఆ ఫంక్షన్ అంక చూడండి ఒకసారి. ఓన్లీ దట్ ఫంక్షన్ నేమ్, parameters and the lines. My question is, if that returns true, what does it mean? What is that it returning? What is the output? Only a function.
Removing subsets that are not frequent, ma'am.
ఎవరు చెప్పారు? Who said?
Deepika, ma'am.
No. Not the correct answer. Partially correct.
It is not subset of that, ma'am.
It is not?
Subset of that. Actually, we have previous one. We have C K-1 value up to C K-1. We compare whether we have subset or not. In
If
this,
if it, what does it say? My question is, if it is returning true, that is, if it is returning true, what does it mean? It is
it
not
means
subset. It is
It is
not
not
yes.
subset.
Yes, that is the correct answer. So if you consider this one, if yes does not belongs to LK minus 1, return true means this total infrequent subset, it is returning true. So it is returning true means that is the clue I have given is name of this subset. Name of this subset ఏంటంటే has infrequent subset. Infrequent. అది ఇన్ఫ్రీక్వెన్సీయా కాదా అనేది చెక్ చేస్తుంది. సో ఇన్ఫ్రీక్వెన్సీ చెక్ చేసేప్పుడు ఏంటంటే ఇఫ్ దిస్ ఈస్ రిటర్నింగ్ ట్రూ ఇట్ ఇండికేట్స్ దట్ it is an infrequent, which means that that is not frequent. If it is not frequent, now you are here. If has infrequent subset with these two parameters c and lk minus 1, if it is returning this, if function is returning true, delete c, else add c to your ck. అర్థమైందా?
Yes, ma'am.
Yes, ma'am.
Raise your hands if you are with me. Okay. Now I will again. What I will do is from here we will see again. Only these two functions we will see again. Then we will go top again. So two sub-functions we are having. So one is going for the joining and one is going for the prune step. This is checking for the a priori property. Join step, the prune step and the a priori property. So in the join step, the parameters here is only one single parameter taking only LK minus 1. In the join step, in the a priori generation, only parameter is LK minus 1, taking this one, finding out these two items and trying to join. And in the infrequent subset function, it is trying to cut down the items which are not frequent and finding out which are not frequent including the subsets is this particular function. So because it is including the subsets, it is taking two parameters c and lk minus 1. C is the candidate k item set, individual candidate k item set, not the capital C. Don't get confused with your capital C and small c. Capital C is this one. Capital C is this small c2, and small c are the item sets inside of your capital C. So what it says here is after joining, you are trying to prune if any items are there, and the pruning we are going to get with the a priori property. So we are checking the subsets of this one, and in the subsets, this function, it is taking the infrequent subset. Infrequent subsets because whichever are not the frequent, if this returns true, you are not going to add that small c into your capital CK if it is returning false. If this function returns false, means your S belongs to LK minus 1, and then if it is false, this if condition, you are going to add that C into CK. Are you with me?
Yes, ma'am.
Yes. Now we'll go top. ఇక్కడికి వెళ్దాం. So where we are is, we are only here. ఇక్కడే ఉన్నాం. We are with the second and the third. So this for your k is equal to 2, lk minus 1 not equal to 5 and k plus plus we are going. So as long as your lk minus 1 is not equal to null, we have to be in this for loop, and for this for loop we have to go for each starting from C2. Starting from C2, we have to call this a priori. This a priori generation will call this infrequent, and this loop we have to go as long as the condition whichever is down is satisfied. Now what is the condition is satisfied here? Now come back to this another for loop inside this one. For each transaction D that belongs to D, now you take subset C K comma T. Now get the subset of T that are candidates here, which is CK comma T here. Now taking your this part, each and every T is nothing but each and every part here. Your I1, I2, I3, this all comes into your T. So this T, check here and find out how many times it has come. Get the subset of T that are candidates, and for each candidate C that belongs to CT, increase that count. So this is the count we are keeping here. This is the count we are getting from your transactional database. So two things we have to go when you are forming this C. ఈ Cని form చేసేప్పుడు two things. One is the prune step following the a priori property, and the other one is the count step from your transactional database. Two things. One thing we are finding out in the infrequent function, and the other thing is scanning your entire total database to get the count. Are you with me?
Yes, ma'am.
Yes, ma'am.
Okay. So that's CT is nothing but your subsets from your CK. You're taking the subsets, each and every subset. T is equal to, if for example, if you're having here, see, for the C2 total 10 are there. So your T value will be 10. Your T is equal to 10, and you will be generating all this 10 and find out this I1, I2 if it is here or not. If it is here, then increase your count C comma C count plus plus. So this is what the count will be increasing, and for each and every count you will add. Now what is your LK is equal to? If your C belongs to CK and C dot C count should be greater than or equal to your minimum support, then only your LK will take into this one. Are you with me?
Yes, ma'am.
Now what finally you will be returning? This is the final thing, is you are going to join your L with your LK. Every time your LK will be is you are joining that with your final LK. This is your final L, output frequent item sets in D, and you keep on making that joining that with this. What is the terminating condition? What is the terminating condition here is, as long as your K minus 1, frequent K minus 1 is that you complete all those things. As long as you get to the frequent item sets, you have to keep on going to the loop again, for loop. Now see here, you first thing is, if you can change this procedure, making this as procedure frequent item subsets. If you take this as frequent item subsets, now whatever returns true, then what you can do, if it is frequent item subsets,
Frequent subset, ma'am.
if it is frequent item set, if it is frequent item set subset, what you will do here, ikkadem chestar.
We will add.
Yes, you will add, ఇది correct గా reverse అవుతుంది. You will add that into this one. That is the thing, the change. If you change this one, you have to change this. Now if you change this, now go back here. ఇక్కడ apriori generation లో CK apriori gen, if you add this, now the same thing you will add, return CK, that is CK here, you are getting this from this CK అనేది ఈ రిటర్న్ వాల్యూ ఇక్కడ వచ్చింది. Now into the CK items, consider the each CT, which is nothing but the subset of your CK. CK లో ఉన్న subsets అన్ని you keep this into CT. find out the count of that CT. If that small c is in your capital CT, increase the count. You do this for all the item sets and you generate your LK only when it is satisfying your minimum support, and finally return your LK. This is what your algorithm is, and how long you have to go is this is your terminating condition. LK does not belongs to null value. Last class we have seen here is, after finding out this, we are trying to find out C4, and in the C4 we could not form the C4 because I3 I5 వచ్చేసిన తర్వాత we did not have the I1 I2 I3 I5 complete set here in your database. As well, the subsets are not satisfied, so we did not have the C4. Because C4 is not there, we could not go for L4, and that becomes your terminating condition. So in the terminating condition, if your L minus 1 does not belongs to 5, until that point you have to keep on doing this, and finally you will get this L, you will return this L, which is the union of all your LK, your last one. This your L is nothing but this one will be your capital L. Your LK total you are giving to L because we did not have the L4. Are you with me?
Yes, ma'am.
Yes, ma'am.
Any other queries? Any other queries? Okay. What are the drawbacks of this Apriori algorithm? If we see the practical thing of this Apriori algorithm, what happens here is you have to scan your this thing. This is the drawback of your fourth point is your drawback of your Apriori algorithm. So what is this fourth one is, each and every time for every subsets to find out the frequency, you have to scan this database for every iteration. For every iteration, you have to scan. So scanning that huge transactional database is the consumption of time. That practically that your transactional database will consist of millions of records. Every time a transaction మొత్తాన్ని count scan చేసి మళ్ళీ count తీయాలి అని అంటే it's a huge process. So that is the drawback of your Apriori steps or the procedure. And one more thing is, in this algorithm we did not do one thing. What is that? In this algorithm, the steps are not shown for one procedure. What is that procedure? Algorithm ఒకసారి top to bottom just go through that. There is no function specified in that. Only two functions specify చేశాడు. Apriori gen and infrequent అనేది జనరేట్ చేశాడు. ఒకటి చేయలేదు. ఇలా చూసిన వెంటనే అర్థమైపోతుంది algorithm. Follow the notation. See the values. లోపల parameters values చూడండి ఒకసారి. We did not find or give the code or the steps for one function. If you take the first function, if you take the first one, ఎక్కడి నుంచి మీకు ఇది స్టార్ట్ అయింది? దిస్ ఫస్ట్ వన్ k is equal to 2 నుంచి స్టార్ట్ అయింది. k is equal to 2 నుంచి స్టార్ట్ అయింది. So if k is equal to 2, if you take this lk minus 1, now this is your starting from this one, starting from this, ఇక్కడ నుంచి స్టార్ట్ అయితే what is your initial L1? Your initial L is 2 minus 1, which is L1. L1 అనేది మీకు ఎక్కడి నుండి వచ్చింది? ఫైండ్ ఫ్రీక్వెంట్ వన్ ఐటమ్ సెట్స్ అనేది వచ్చింది. నేను ఈ మెథడ్ చెప్పాను, అసలు ఇక్కడ ఎక్కడన్నా ఈ మెథడ్ ఉందా? ఈ మెథడ్ అనేది ఇక్కడ లేదు. దేనికి లేదు? ఫంక్షన్ ఇందులో ఏ ప్రొసీజర్ మనం ఎక్స్ప్లెయిన్ చేయలేదు, స్టెప్స్ లేవు అని అంటే ఫైండ్ ఫ్రీక్వెంట్ వన్ ఐటమ్ సెట్స్ ఆఫ్ D is not having the steps. అర్థమవుతుందా? ఎక్కడి నుంచి స్టార్ట్ అవుతుందంటే C2 నుంచి స్టార్ట్ అవుతుంది, C1 నుంచి లేదు ఇక్కడ. అంటే వీ హ్యావ్ టు క్రియేట్ వాట్ ఈస్ అవర్ C1 నుంచి L1 అనేది ఫైండ్ అవుట్ చేయాలి. సో యూ కీప్ the procedure for C1 to generate your C1, and from G1 how did you get this L1, which is finding the frequent one item sets. Now దీనికి ప్రొసీజర్ రేపు మీరు రాయండి, which is not given here. ఇది రాసి what you do is you show me when we start tomorrow's class. Maybe Friday na? Tomorrow I'll tell. But meanwhile, you write the function for this one, finding one frequent item sets and store that into L1. That is the procedure which is not there in your textbook, which you have to write. L1 anedi, what I'm saying is L1 you are getting from C1. C1 anedi ela vachindi, what are the steps here, what are the parameters we can take in that function, how do we get this one, and then finding out this L1. దానికి ఒక 4-5 లైన్లు you write the steps for that. Any more queries with this algorithm today? This is the style of your data mining algorithms from here onwards. First you will try to solve the problem. After the problem, when we are solving that, we will see the notations. After we are familiar with the sequence of steps and the notations, then we will go for the algorithm. And for every functionality, the same procedure will be there. Yes. Now, any questions in this? Okay then. And Veda Prakash and Aparna, you try to take the attendance in the beginning itself, in the
Yes, ma'am.
first 5 minutes, and then you stop taking attendance. Don't take whoever joins late or something. Whoever wants the class, they will attend, and we will see the summary of the attendees at the end of the semester.
Okay.
So every day note down these absentees. There will not be any alerts or reminders for the absentees except the initial classes. We will not waste the time taking the attendance and talking about them, but definitely there will be the consequences of these absentees at the end of the semester. That is what the final message, if at all you want to give to your friends. Okay then. Yeah, thank you all. And one more thing, yeah, boys, leave now, disconnect boys.
Oh.
బాయ్స్ లీవ్ అంటే అందరూ లీవ్ అయ్యారు, గర్ల్స్ ఉండమన్నాను. మహేష్ ఉన్నాడు. వెల్కమ్ మహేష్, వెల్కమ్ టు ద గర్ల్స్ గ్రూప్.
I'm exiting.
ఏంటి
Exiting room.
ఎంతసేపు అయ్యా నోరు మూసుకొని డిస్కనెక్ట్ అవుతారుగా. ఓకే, ఎనీ అదర్ బాయ్స్?
మ్యామ్.
ఇంకెవరు లేరు కదా? ఓకే,
జయకుమార్
జయకుమార్. బట్ ఏంటి నాకు అసలు అర్థం అవట్లేదు. నువ్వు మెంటలీ డిస్టార్టెడా ఏంటి అసలు? One day he called and he said he's having some signal problem and some reasons he said. ITS, CSC na?
సిఎస్సి మ్యామ్. సిఎస్సి మ్యామ్.
ఒకసారి కాల్ చేయమని చెప్పు నాకు తర్వాత సెపరేట్గా.
ఓకే మ్యామ్. ఓకే.
అండ్ ఐ థింక్ ఈస్ ఫ్రమ్ విజయనగరం. మేడంకి ఏదో విజయనగరంలో పని ఉందంటే అందుకు ఫోన్ చేయమన్నారని చెప్పు. నాట్ దట్ లైక్ అటెండెన్స్ గురించి ఏం మాట్లాడద్దు.
ఓకే మ్యామ్.
మీతో ఏదో చాలా బాగా మాట్లాడతారంట మేడం అని చెప్పు.
ఓకే మ్యామ్.
We will treat him. Yeah, main thing why I asked you is when you're sitting in front of the cameras or for the class, this is as equal as the class. Not that you're sitting at homes. మూడులు పెట్టుకొని నైటీలతోటి అప్పుడే నిద్ర లేచి ఇలాంటివి మటుకు అలాగా సిస్టమ్ ముందు కూర్చోవద్దు. దట్ ఈస్ ద పర్పస్ ఐ కాల్డ్. ఎస్పెషల్లీ ముడి పెట్టుకొని కూర్చోవద్దు. డోంట్ గివ్ దట్ కైండ్ ఆఫ్ గెస్చర్ వెన్ యూర్ సిట్టింగ్ ఇన్ ఫ్రంట్ ఆఫ్ ద కెమెరా. నైటీలో ఒకటి. వేకప్ ఎర్లీ ఇన్ ద మార్నింగ్, గెట్ రెడీ, టేక్ బాత్, ఫ్రెష్గా నీట్గా కూర్చోండి. అండర్స్టాండ్ వాట్ ఐఎమ్ సేయింగ్? అండ్ I appreciate the girls, those who are connecting for the Python and this deep learning classes. కనెక్ట్ అవ్వండి. ఇంట్రెస్ట్ ఉన్నవాళ్ళు. ఇట్ ఈస్ నాట్ అంటే అంత నాట్ ఇంపార్టెంట్, ఇట్ ఈస్ ఇంపార్టెంట్ ఓన్లీ, నాట్ కంపల్షన్, బట్ ఇట్ ఈస్ గుడ్ ఇఫ్ యూ గెట్ కనెక్టెడ్ ఫర్ దోస్ క్లాసెస్ ఓన్లీ వన్స్ వీఆర్ గోయింగ్. అండ్ బెటర్ ఆల్ ఆఫ్ యూ పర్చేస్ ద సిస్టమ్స్. ఫోన్లో వినొద్దు, సిస్టమ్స్ కొనుక్కోండి. ఇంట్లో ఇది మటుకు ఫోర్స్ చేసి ఇంట్లో కొనిచ్చండి. ఓకే, అండ్ ట్రై టు ఫాలో ఆల్ ద క్లాసెస్. దట్స్ ఇట్. ఓకే
మ్యామ్, సింధుకి యాక్చువల్లీ కేరాస్ ప్యాకేజ్ డిస్ప్లే కూడా అవ్వట్లేదండి మ్యామ్. సర్చింగ్ చేసినప్పుడు ఇన్స్టాల్ ప్యాకేజెస్.
చేసా. ఐ హావ్ ఇన్స్టాల్ ఇట్. నేను చేసా.
she got
ఓకే. ఓకే.
థ్యాంక్ యూ.
నాకు I want video girls to be neat, to be attended. Why? Because I don't want to scold girls in front of boys and all. So don't give me that chance. Okay then. Yeah.
Thank you,
See
ma'am.
you all.
Thank you.
And I don't think tomorrow I will be connecting. Tomorrow Friday kada. Then afternoon I have. Maybe Saturday we will meet. Saturday I'll take the class.
ఓకే మ్యామ్.
Yeah.
మ్యామ్
And
ఈరోజు ఈవినింగ్ యాజ్ యూజువల్ కదా మ్యామ్ 7కి?
ఈవినింగ్ 7కి ఉంటుంది. ఈవినింగ్ 7కి క్లాస్ అయితే ఉంటుంది.
ఓకే మ్యామ్, నేను ఇన్ఫార్మ్ చేస్తాను.
ఓకే దెన్.
Thank you, ma'am.
Yeah, thank you.
Thank you, ma'am.
Thank you.
Thank you, ma'am.